Are you having a hard time in your basic calculus lesson? Oh well, now's your fortunate day, cause Mathmania Korean is gonna save the day. Annyeong 여러분! So this is a new episode of the Mathmania Korean tutorial.
So hi there guys, it's me Shan, your coach for the day. So today we're gonna talk about the application of derivatives. So let's not dilly-dally, come on, let's go!
Derivatives. So what is a derivative? Do you all know what a derivative is? Before anything else, let's have some recap about the definition of derivatives. So derivative is a way to show rate of change. That is the amount by which a function is changing at one given point. The definition of a derivative can be approached in two different ways. One is geometrical, referred to as a slope of a curve, and the other one is physical, which is called as a rate of change. So now that we remembered what derivatives are, let's proceed to its applications. The application of derivatives. There are many applications of derivatives in real-life situations. One of these is the rectilinear motion. This was tackled by my co-coaches in their videos. So this time, we are going to solve problems involving related rates. Some late night alone time, the owl is flying with the wind, searching food for dinner. And as he was flying, a mouse was spotted near a lamppost. Right away, the owl dove to get the mouse. So right at this moment, the distance between the owl and the mouse is 20 feet, going straight down with a velocity of 10 feet per second. Now the street light is 25 feet high, and the mouse is 15 feet away from the base of the lamppost. A shadow is casted due to the light emitted by the lamppost, and as the owl goes further down, the shadow is going to move left also. So the question is, at what rate is the shadow of the owl moving? So together, let's solve the problem. The light from the lamppost is blocked by the owl, which made a shadow behind it. So if you are going to draw a straight line from the source of light through the owl until it hits the ground, you're going to get the location of the shadow. So if you draw lines from the base of the lamppost through the mouse to the shadow, you can get a right triangle. And so, let's assign some variables. So the distance between the mouse and the owl will be the letter y, and the distance between the mouse and the shadow will be the letter x. So here comes our blackboard. So we can use this to illustrate the situation. So we have the given. Y is equal to 20. dy over dt is equal to 10 feet per second, while x is unknown, and dx over dt, or the rate at which the shadow of the owl is moving, is also unknown. In order to figure out what dx over dt is, we must first come up with the relationship between x and y. So the two triangles here both have right angles, and also they share the same angle. So according to this theorem, if two angles of a triangle have measures equal to the measures of two angles of another triangle, then the triangles are similar. Which explains that these two triangles are similar triangles. Moreover, corresponding sides of similar polygons are in proportion. So now we can say that x over y is equal to x plus 15 over 25. So this is the ratio of the corresponding sides of the two triangles. So let's simplify this equation by using cross multiplication. So the result is 25x is equal to xy plus 15y. After this, we are going to find the derivative of the equation. So it would result to 25 times dx over dt is equal to dx over dt times y plus x times dy over dt plus 15 times dy over dt. So in order to find the value of dx over dt, we must first find the value of x, which is the only missing value in order for us to find the value of dx over dt. So let's find the value of x. Let's use the simplified equation 25x is equal to 20x plus 15y. So we all know that y is equal to 20, and so let's substitute 20 to y. 25x is equal to 20x plus 15 times 20. 25x minus 20x is equal to 300, which is the result by transposing 20x to the left side. And 25 minus 20x is equal to 5x, and 15 times 20 is equal to 300. So 5x is equal to 300. Divide both sides by 5 so we could find the value of x. So x is equal to 60. So now that we all know the values needed for us to solve the value of dx over dt, or the derivative of x with respect to time, so let's start solving for its value. So 25 times dx over dt is equal to dx over dt times y plus x times dy over dt plus 15 times dy over dt. So let's substitute the values of y and dy over dt and also the x to the equation, which would result to 25 times dx over dt is equal to 20 times dx over dt plus 60 times negative 10 plus 15 times negative 10. So combine like terms, which would result to 5 times dx over dt is equal to negative 375. So let's divide both sides by 5 in order for us to find the value of dx over dt. So divide both sides. So dx over dt is equal to negative 75 feet per second. So the rate in which the shadow is moving to the left is equal to negative 75 feet per second. So the negative here explains that the x is decreasing and is moving to the left. Just a piece of cake, right? Just remember, be like Pooh. Keep thinking. So did you understand the lesson we had for today? I hope it helped you. So if you like this video and you understand more and learn more about the lesson, please click like, let me know in the comment section below, share this to help a friend or someone, and subscribe for more videos.
So that's it. Once again, it's me, Shang. Watch out for more episodes. See ya! Yeah, yeah, yeah.